Chapter 4, Lesson 4. Our essential question is, how can you find the lengths of line segments in a coordinate plane? It says you can use ordered pairs to represent vertices of polygons to draw a polygon in a coordinate plane, plot, and connect the ordered pairs. You do not have to take any of that down into your notebook. Example 1. Let's look at the study tip. After you plot the vertices, connect them in order to draw the polygon. Important. All right. The vertices of a quadrilateral are A, 2 and 4, B, 3 and 9, C, 7 and 8, D, 8 and 1. Now, the thing to point out first is you have an x-axis and a y-axis. X you always put first, Y you put second. Goes that way in the alphabet too, X and Y. X first, Y second. Plot each of these coordinates on the grid, then as was stated before, start with the first one, which is A, and with a straight edge, connect it to B, straight edge it to C, straight edge to D, and D will go back to A because you are working with a polygon, so it has to be a closed figure. Do the on your own numbers 1 through 4. Come back when you're done. Alright, here's the key idea for finding distances in the first quadrant. You can find the length of a horizontal or vertical line segment in a coordinate plane by using the coordinates at the endpoints. When the x coordinates are the same, the vertical distance between the points is the difference of the y coordinates. When the y coordinates are the same, the horizontal distance between the points is the difference of the x coordinates. Be sure to subtract the lesser coordinate from the greater coordinate. Confusing, but we'll look at it with some examples. You do not have to write that down. Finding a perimeter. All right, the vertices of a rectangle are F, G, H, and J, and they tell you what the coordinates are. And it said draw the the rectangle in a coordinate plane and find its perimeter. Easy enough. The length is the horizontal distance between F and G. That's the length. That is the difference. I'm sorry, you take F 1 and then G7 right here, and the difference between the two gives you the horizontal difference on the x-axis. All right, going across, x-axis going this way, you have 1 and you have 7. That's your x-axis. Those are your numbers. 7 minus 1 is 6. So the answer here is 6. The width is the vertical distance. So now you have the vertical y, and that's between G and H. There you subtract the 6. Sorry, you take the 2 away from the 6. 6 minus 2. So if you know that your x-axis is always the first number and your y-axis is always the second number, you can subtract appropriately. So anytime you're trying to figure out what is the difference between, or the length actually of this axis, excuse me, which is x, you would subtract the first 2 digits. If you're trying to find the length of the y-axis, okay, the coordinates are the second ones. So then you take 2 times 6 for the 2 horizontal and 2 times 4 for the 2 vertical, and you get 20. So that is the perimeter of that rectangle on a coordinate plane. Let's take a look at your real life application on this. If the grid of the exhibits at the zoo, in a grid of the exhibits at a zoo, the vertices of the giraffe exhibit are, and they give you all of them, E, F, G, and H. The coordinates are measured in feet. What is the area of the giraffe exhibit? Well, let's take a look. First, you plot and connect the vertices using a coordinate grid to form a trapezoid. Use the coordinates to find the length of the bases and the height. Okay? Here's where you're using what we just did in the last example. Base 1. Okay, you need base 1. It's a trapezoid. So here's base 1. And we need to find out the difference between E and F for the X coordinate. So you've got 60 minus 0. So base 1 is 60. You can do the same thing with base 2. 100 minus 0 is 100. For the height, you're going to do 90 minus 30. And that's 60. So now you're going to use the formula for the area of a trapezoid. Once you fill in all the numbers, you have 1/2 of 60, right here. And then in parentheses, you have it times 60 plus 100. So you do this first, 160, and fill in the rest. So the area of the giraffe exhibit is 4,800 square feet. Please do numbers 5 and 6 on your own. And let's see if you need to come back. Nope. And then I will see you in class tomorrow.